So if you need to evaluate this summation, one way, which is just to give the general idea of what you're supposed to be finding, would be to plug in each individual number for I and add them up. So the first term is found by doing 3 squared plus 2 times 3. There's 1. Now we just need to do it, 66 more times, plus 4 squared plus 2 times 4. So this is I equals 3. This is the I equals 4 term. You have to do that until you get to I equals 70. And you have to add all those up. So obviously we don't want to do that. So that's why we have these little formulas to help us here. If we can just break this top part down so that it looks like this, so it's just summing up a bunch of i's, then we can find out what that sum is by plugging the top number, the n, into this formula. And if we could just break this down so it's just the sum of I squared, we can find out what the sum is without having to do it 3, then 4, then 5, then 6, and 7. We don't have to do it all those 67 times by just plugging in what we're summing it up to here. This formula doesn't work though unless you start on I equals 1. Ours does not start on I equals 1. So here's what we can do. We can start off saying that it's just starting from 1 to 70, but obviously these two things aren't equal. Here's how we're going to make them equal. We're going to subtract the first term from this sequence, okay? Because if this is adding them up all from 1 to 70, if we subtract the first term and then the second term from it, then what this whole expression will be really just 3 to 70, because we've taken out the first and the second. So there's the first and the second term in the sequence. And I got those from just plugging in 1 into my formula for my sequence. 1 squared is 1, plus 2 times 1 is 3. 2 squared is 4. 4 plus 2 times 2 is 4. So 4 plus 4 gives me 8. And I want to subtract those out of the series because I'm trying to find out the sum of the series from 3 to 70, not 1 to 70. But again, the whole reason I wanted to have a 1 to 70 over here is because now I get to apply these formulas if I can just break it down. So with every summation, you can use the summation symbol kind of like the distributive property. So that distributive property, or that's not the distributive property, that's similar. The summation breaks up to apply to the I squared, and the summation breaks up to the 2i. But you'll notice I factored out the 2. Because if each number is being multiplied by 2, you might as well just divide it out, write it on the outside. So you can always do that, write the constant number on the outside. And so we don't want to do 1 squared plus 2 squared plus 3 squared plus 4 squared. We don't want to do that 70 times. Instead, we have this formula to help us. If you're trying to add them up all the way to 70, you can instead plug them in like this. So there, this piece goes with this piece here. Since it's the sum of I squared, I get to plug that n, which is 70 in this case, into the formula. 70 plus 1 plus 2 times 70 plus 1 in for here. And then I can plug in 70 in. Since this is I to the first power, I have to use this formula up here. That's the one that has I to the first. So 70 plus 70 times 71 over 2. And then in that case I had factored out a 2. That's why that was left on the outside over here. So this, using the formulas, translates to this, and then you just have to crunch these numbers to find out what the whole summation equals to. So plug those in the calculator, plug that in the calculator, subtract by 11, and that'll be your answer.